What is the subject matter today? Well, it's definitions. Okay, do we need definitions? Well, yeah, I think we do, but some people don't believe in definitions, and they think that when you define words, you are doing semantics. And this is what they say. They say, you're doing semantics, Bill. They don't like definitions because it destroys their religions. Okay, so we have all these flat universes, flat earthers, and electric universes, all these flatlanders. And they all believe in not defining words. They don't accept the definition of words. Why? Because it destroys their religion, and so they accuse you of doing semantics. And yeah, science is 150% semantics. You had better define your terms before you start your presentation, so we know what you're talking about. Okay. Okay, so one fellow, he goes in there and he defines one word, intangible. Okay, he says intangible, unable to be touched or grasped and having physical presence. Well, here we see how definitions are important because either intangible means unable to be touched or it is physical presence. Those two are not synonyms. Those two are not the same. Okay. And so if you look up physical, it says relating to things perceived through the senses as opposed to the mind, tangible or concrete. So, if you have the wrong definition, an irrational definition of the word physical, and then you put it into the word intangible and say, look, it's that which has physical presence, then we have a problem. Okay, because that's not what tangibility means or intangible means. Okay. And so the fellow continues, says, oxymoron, a figure of speech in which apparently contradictory terms appear in conjunction. And so he says intangible physical is an oxymoron. Yeah, because he defined physical as that which you can touch, see, using the senses. That's where the problem is. Okay, and that's not what physical means because physical is a synonym of object, of thing, and it's not that which you can see, touch, smell, taste, hear. An object is that which has shape. All the others require a second object, first of all, and second requires a test. You need to smell it, you need to touch it, you need to see it. Okay, so we need two objects, according to them, to define object, and then you need an interview, you need an experiment. And so we won't know until you finish your experiment. Here you have the table on the other side of the universe. It's in the Klingon's living room, and the table is not an object. It's not an object because I can't see it, I can't touch it, smell it, hear it, taste it. And so it's not an object until I do. And some people say, well, it is amenable. You can touch it. It doesn't mean you have to touch it, it means you can touch it. Well, we won't know until I touch it, will we? Until I run the experiment and touch it. So, and besides, I need another object, which is me, to touch it. The asteroid is not an object, the moon is not an object until the asteroid hits the moon. Then they both become objects suddenly. Until then, and they haven't touched each other, so they're not objects. And the blind man can't see the moon or the asteroid. And so he says, neither one is an object, I can't see it. So, yeah, we have irrational definitions. The see-touch criteria are irrational. Okay, so if we start on the wrong side, of course, everything's wrong. Here's the word physical in the Wikipedia again. Dictionary.com says, of or relating to the body. Yeah, physical and body are synonyms. Yeah. Of or relating to that which is material. Okay, the physical universe. Okay, not necessarily so, not exactly, but close. Noting or pertaining to the properties of matter and energy. Hopefully nothing to energy because energy has nothing to do with physical. Energy is a concept, belongs to religion. Because there's 500 types of energies out there, potential energy, kinetic energy. They have so many energies out there that, and now Putin is shutting down the energy, so we won't have energy here in Germany. So we'll find out what energy is, I guess. The absence of, at least. Tending to touch, hug, pat. No. Physical has nothing to do with touch, okay? But we use these words of ordinary speech. We bring them into physics. We say, I found them in the dictionary. Bad way of doing physics. Okay? Now, in physics, we have to define the terms. And if the word in the dictionary is irrational, we throw it in the garbage can, the whole dictionary. Okay? No, we have to redefine the word. If it's broken, we fix it. Okay? And so if the word physical is broken, we have to fix it. Physical in Wikipedia, physical object or physical body, is a collection of matter with a defined blah, 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 blah. Yeah, no, it's not a collection of matter. Collection is mereology. Okay, mereology is religion, has nothing to do with science. Mereology is what something is made of. We don't care what something is made of. When we talk about an object, a thing, a physical entity, we point and we say, that's a tree. It's a physical thing. Okay, that's the way it works. We don't say, well, what is it made out of? What is the table made of? Well, it's made out of atoms. First of all, it's made out of wood. Wood is made out of molecules out of atoms, et cetera, et cetera. Electrons, whatever. So we don't do any of that. That's mereology. That's religion. We don't use that. What something is made out of. And so we call it the fallacy of tangibility. Physical has nothing to do with the senses. Okay? So we're so used to thinking of physical, of object, of thing as something that you can see or touch. We equate that word, the word physical or the word object thing, with the word exist, because people think that exist is that which you can see or touch, and object is that which you can see or touch. Therefore, the two words are synonyms. As Mr. David Hume and Mr. Immanuel Kant said in the 18th century, they said, we don't know what the word exist adds to the word object, to the thing. And yeah, what it adds is location. That's what it adds, Mr. Hume, Mr. Kant. Okay? Anyways, physical is not equal to the senses. Okay? We don't use the senses to determine something that is physical. Not in physics. In ordinary speech, that's different. That's religion. Okay? In physics, it's that which has shape. And so tangibility, visibility, olfactable, audible, testable, tasteable, none of those have anything to do with the word physical. Okay? And that's where the problem is. Physical, that which has shape. We don't use the senses. Can we see, touch, or smell, or anything? The Klingons table on the other side of the universe? Absolutely not. Can we? Well, we don't know until we run the test. Anyways, you need two objects to do touch. So hopefully that's a bad criteria to begin with, and to do see as well. Okay, so yeah, they say, Bill, what do you mean by shape? All these flatlanders, they say, oh, I got you, Bill. I can play that game too. I can play semantics too. What do you mean by shape? Oh, my God. That's how they come up again. So they say, that which has shape, that's an object, a thing, And they say, well, so what do you mean by shape? Well, the first question is, why don't you ask, what do you mean by that? What do you mean by which? What do you mean by has? I mean, are those words easier to define than shape? Why did you ask about shape? Just a thought, they come at you like they know something. They're so smart, They say, oh, what do you mean by shape, Bill? Well, here's your answer, okay? The issue here is, how do we define the word thing for the purposes of physics? That's what it's all about. And we either define them as see, touch, which is what the mathematicians have today, what they use today because they got it out of the dictionary that they did not write. The dictionaries were written by grammarians, English majors, librarians maybe. These people who have no stake in physics, they put the words in the dictionary. And these people just go to the dictionary and say, well, let's see what an object is. Oh, it's that which you can see or touch. And they just say, well, then I'll go with this word. No, if it's broken, you got to fix it. We fixed it. That which has shape. Okay? So you have the idiots of math, and they use all these words like see, touch, to define object. They use experiments. They say, we're going to see and touch, and so we're going to go to the lab. And so, here you have it, magnet, okay? Those two dark things there. So can you see or touch what's in between the so-called magnetic field, that concept? Can you see or touch it? And here's another experiment. Here's a spoon, okay? I'm going to let go of it, and it always falls to the floor. Let's make it scientific. Let's make it repeatable. Okay, we let it go to the floor. I didn't drop it. It just fell from my hands. Always falls to the floor. Try it at home. You don't believe me. Always in the presence of a relativist, okay? Yeah, when you do that, you find that it always falls to the floor. Well, can you see or touch anything above or below other than the air? And the answer is no. So what experiment are you going to run to detect how Mother Nature or what Mother Nature uses to do gravity or magnetism if you can't see or touch it? You can't smell it either. Can't taste it. Can't hear it. So we have no idea what's in there. And if you have no idea what's in there, you're not going to determine it through an experiment. You can only visualize it. You can think about it. You can try to imagine, what could Mother Nature be using to do gravity? What could Mother Nature be using to do magnetism? Then you can try to explain the mechanism, how that thing works. Okay, but you got to make it visible so that you can visualize it for someone else, so that someone can see. Okay, I see what you got in your mind, how you visualize that magnetism worked, or how you visualize that gravity works. But these people say, we're going to run an experiment. We're going to go to the lab. What are you going to go to the lab for? We did all the experiments we ever needed to determine gravity. In other words, to understand what happens during gravity, the description of what we call gravity. Gravity is this. Let go of this and it falls to the floor. That's the only experiment you'll ever need. Now, explain it. How did that happen? What caused it to fall to the floor and not to the ceiling? That's what you got to do. That's a physicist, okay? And we don't do equations, but that's what the mathematicians do. They present evidence. Evidence for what? What evidence are you going to present for gravity? for the cause, the mechanism of gravity. Then they try to talk about proof and that they have knowledge that they have accumulated. Well, when you know something, you have religion, because that means you already know it. So there's nothing that anybody can do to change your mind because you know it. And so knowledge is individual. And knowledge means that you already know it. And when you know something, you know God. Nobody's going to take God away from you. Okay, so you know God exists. God is there. I saw God. He talked to me. Okay, so what can we say? You know it. And what they do is, they move concepts around, they persuade, they win prizes. None of that is what we do in science. Okay, the scientist does all the other things on the right there. Okay, and you can't. If you're going to define the word object, the word thing, for the purposes of physics, you need to determine whether you're going to use a see-touch criteria, which mathematicians use, or you're going to use the one we propose here, which is that which has shape. Okay, so this is not a question of saying, what do you mean by shape? Well, what happened? Did you miss kindergarten or something? I mean, you don't know what shape is? Go to a kindergarten, with a cube and a sphere, same material, same color, same everything, except, the difference between a cube and a sphere, if you know what the difference is. Maybe a flatlander wouldn't know, but I mean, a normal person would know. And you go to a kindergarten and you say, well, kids, what's the difference between these two? They see the color the same, the volume is the same, everything's the same. They say, it's the shape. That's what they would tell you. They would educate you. They would tell you that the difference is the shape. That's what shape is. That's all you need to know. What we need to determine is the difference between mathematics and science. And mathematicians use the criteria of see-touch, which is irrational. And what we use here, what we propose, is that which has shape. Then you can use the word consistently. There's no object in the universe that you can even imagine that doesn't have shape. It's the universal property. All objects have it. On the other hand, see-touch, well, we can't see all objects, can we? We can't see gravity, right? Whatever causes gravity, whether it's the particles that push or the ropes that are pulling, right? We can't see the mediator of gravity. So not all objects can be seen, not all objects can be touched. Okay? And so it's an irrational definition, the one that people have out there. 99% of humanity, spiritualists, right? They believe in see-touch. They want to prove, they want to sense, they want to run an experiment. Okay, so physics, what is that? Rational explanations of causes and mechanisms. Foundations of physics include those words. You must define these words if you want to do physics. You cannot elude defining them. You need to define the first word of physics, object. You need to define what an object is, because physics cannot be done without an object. Okay, you can't do physics unless there are objects out there. So the first word a physicist has to define is the word object. Then we have to have distance. We need to know what distance is, separation between two objects, location, the set of distances, motion, two or more locations, exist, an object that has location, concept, a word that invokes or embodies two objects. Okay, so we need two objects because a concept is a relation, a contrast, essentially a relation between two objects. And you have to have a recorder, human, to conceptualize. You can't do it without having a mind. Okay? Mother Nature, she doesn't understand. She only works with objects. She doesn't understand concepts. All concepts were invented by man, especially mathematical concepts, relations, ratios and so on. Anyways, and space, that which doesn't have shape. The definition of the word object destroys all religions. Once you define the word object, people have to choose whether their God is an object or a concept. And I put that question to a bunch of Palestinians who were in Scotland with me, giving a presentation at a university over there in St. Andrews. And I put that question to them. They were all Muslims. And I asked them whether their God, Allah, was an object or a concept. Well, one guy said, well, it's neither. Another guy said, it's both. He's both. And the third guy said, well, if I knew whether God was an object or a concept or what he looks like, then God wouldn't be that great, would he? Those are the kind of answers you're going to get. Okay, so here we continue. Paul says, an object can have internal motion, yet no external motion. Okay, so he's starting to talk about motions within objects. So he says, look, you have things like clouds and fire and tornadoes, and they already have embodied motion. They don't stand still. They, from frame to frame in the movie, they're moving. At least one atom moves in there, and it's not the same object as it was before. It wasn't the same shape. That's essentially his argument. And what can we say? Poor fellow, these poor people. And this is the answer, okay? You must define the word object before you define the word distance, location, motion, exist, etc. Concept. all those words are dependent on the word object. So you can't talk about motion before you define the word object. So you can't say, well, all objects have motion. No, that's not true. Not all objects can move, okay? And the fact that objects do move, to define motion, you need to define it as two or more locations. The problem there is that a square does not have location to begin with. And if a square doesn't have location, it cannot have motion. You cannot conceptualize the motion of a square, except in a cartoon, okay? Because it's an object because it has shape, but it has no location. Nothing that has, or anything that has 2D doesn't have location. And so the issue is that not all objects move, first of all, but that's irrelevant. You have to define the word object before you define the word motion. This guy's starting to introduce the word motion in the definition of objects. As the cloud moves, it changes its shape and so on. I could take a picture of a cloud, assuming I had God's camera and I have every atom in there, right? And I put it in a snapshot in a one frame of the film. And in that frame of the film, that thing that I see there is called a cloud. And in there, in a photograph, there's no atom that is moving. It'll move in the next frame, but not in that frame. Okay? Shape is a static concept. Okay? So don't talk about motion. You're spinning your wheels out there. Another fellow says the following. Says, solid is object. Heated solid turns to liquid, so it's object. Heated liquid turns to gas, so it's an object. But if you heat up a gas, so it's plasma, then it isn't an object. Because plasma is not an object. Plasma is not a thing. Plasma is a thing in motion. Plasma is a word that embodies motion, just like the word energy embodies motion. You cannot take a picture of energy, of plasma, or of force, because these words already embody motion. It's like taking a picture of running. If I take a picture of running, I won't get running. I'll get a man, maybe with one leg in front of the other. He's solid, he's static in that picture. And you can't say he's running. I don't know if he's running. That's not running. Running, I need two frames because it's a verb. I need two frames at least in the universal movie. Plasma requires two frames, okay? And again, what happens is these people are introducing motion already. And he's saying a liquid is solid that is heated. No, that's not what a liquid is. I have water, okay? And I point to water. And water has shape. There you see a liquid, we call it water, okay? That's supposed to be water. And that's a snapshot of water, okay? Does it have shape? We're done. If it has shape, we're done. Gas. We have a bundle of atoms, right? We call it gas. It's a blob of gas. The astronaut threw gas in space. He popped the balloon with colored gas. He takes a snapshot of that gas as it's expanding or that blob is moving through space here, right? So he takes a snapshot of that colorful gas. Can he do that? Yeah. When he shows you the picture, that's gas, what you see in the picture. He calls it gas. So gas is a physical object. You say, but it's made out of atoms. Well, so is the table. Just because the table doesn't break apart, it's not an object. Again, mereology. Mereology is what something is made out of. That's not what an object is. An object is that thing I point to in a picture, in a static image. Okay? You can't do that with plasma. I take a picture of plasma and I don't get plasma. Okay? Why? Because what's missing is the ionized part. The little electron leaving, moving, being expelled from the atom. That motion, I cannot synthesize it in a photograph. Okay? And that's what the electric universes and people like this fellow, who probably is one, don't understand. Plasma is not an object because we don't heat up solid to liquid to gas to plasma. That's not how you determine what an object is. The way we determine is we say, does it have shape in a single frame of the movie? And you can do that with solid, you can do that with liquid and gas. You can't do that with plasma because plasma includes the word ionized in it. Ionize is a verb. Something is happening. There's motion in there. So it's a verb for the purposes of physics. Okay? So, you might say motion is a noun in ordinary speech, not in science. In science, the word motion is a verb. You can't say motion is a noun. You can't talk about motion. Motion is what something does, meaning verb, motion. Two or more locations. Another fellow along the same line says temperature is a scalar field. Whatever a field is. What is it, like a poppy field, maybe a football field? I don't know. Is temperature a concept? And again, these people have never defined terms, so they don't know whether it's a concept or not. Very simple. Define the word concept, and you'll find out whether temperature is a concept. You just have to define the word concept. Okay? And yeah, concept, a word that invokes or embodies two objects. Does temperature involve two objects in any way, shape, or form in the notion, in the concept we have of the word temperature? Of course it does. Temperature, hopefully, is a relation. Okay. And another fellow says, ropes are a concept. Rope is a concept, he says. Okay. Because it's just your theory. Oh, so it's, anything that's my theory is just a concept, I guess. You were talking about gravity existing in one of your previous videos as well. No, hopefully not. I never said that gravity exists. So you heard wrong, but you're welcome to, unless it was a slip of the tongue, but never do I say that a concept exists. Okay? Concepts happen, especially dynamic concepts like gravity. Okay? Electricity definitely exists. No, you can't say that electricity exists, because electricity is a moving thing. Okay? Electricity, according to the official version, right, is a bunch of electrons that are moving from atom to atom. It's a series of moving atoms. So you can't say electricity exists, because exist is object with location, not with motion. Okay? He says, just try touching electricity. So this poor fellow goes throughout his outlets to find out every morning. He says, let's see if electricity is an object. He sticks his fingers in there and gives a zap, and he says, oh yeah, electricity is an object because it hit my hand. It touched me. That's how he determines what an object is in physics. Fields exist. Okay, yeah, maybe, I guess a football field, maybe. How else would motors, generators, transformers, compasses, etc. work if there weren't any magnetic fields? Yeah, field is a concept. Concepts don't exist in physics. Concepts exist in ordinary speech because no one defined the word exist in the last 3,000 years. So people say, oh, love exists. Intelligence exists. No, first you got to define exist, then we'll know whether, love exists. And you can't use concepts with the word exist in physics, in science. In ordinary speech, you can say whatever you want. Okay, you can say God exists if you want, no problem. But in physics, you must define the word exist. Object that has location. Location is a static concept, so is object. Both of these are static concepts, right? So to say that a field exists is irrational. Field cannot exist because field is a bunch of numbers, and a bunch of numbers does not an object make. Okay? And you just made a video arguing semantics. Yeah, again, all these people say, Bill, what you're doing is semantics. Stop doing semantics, Bill. You're driving us nuts with semantics. No, physics is 150% semantics. If you don't do semantics, you don't define your terms, we have no idea what you're saying. We don't know what's going through your tiny little brain. Okay, so please define your term before you talk. Okay, and so these are irrational concepts that mathematicians treat as objects, move around, and fed to you in high school or maybe in college. So if you use any of these words in any way, shape, or form and you introduce them into physics, you are an irrational individual. You are just a mathematician. You are, or maybe you're just parroting what the mathematicians fed you in high school or college. That's all you're doing. So if you're doing physical interpretations with any of these concepts, okay, then you got a problem. That means you don't understand the basics of physics. Okay? That's where, and so here we treat you as an idiot. What is an idiot? A person with big ideas. Okay, so here we have definition of definition. What is a definition then? Scientific definition. Okay, so limitation placed on the extent or usage of a word. Okay, I use really a terrible example, but I think it drives home the point, so I hope you'll bear with me. If you say it's white and has wings, what are you talking about, a swan or the White House? And how are you going to zero in on which one I'm talking about? And you say, well, it's a building. Well, now you've eliminated at least the bird. And that's more or less what a definition is. You put things in there so you eliminate all other things. You limit the usage and extent of that word. Okay? And so that is a scientific definition. Okay? Definition is not the same as meaning. People say, oh, it's the meaning of a word. Absolutely not. Definition is what a prosecutor proposes. Meaning is what the juror gets out of it. Okay? One's on the receiving end, the other one's on the emitting end, okay, so to speak. Meaning has to do with how a definition is interpreted, how it's processed, what you're receiving. That's meaning. If a definition is on the emitting end, meaning is on the receiving end. A prosecutor issues definitions, a juror infers meaning. Okay. And to close up, here we have it. If you don't like my definition, no problem. You can't use any of these fallacies to counteract it. You can't say it's the fallacy of tradition. This definition has been used for hundreds of years. According to the etymology, Now, we don't care about where it started or how badly our forefathers defined the terms. Okay, so that's the first one you got to eliminate. Then you have the fallacy of authority. That's what the dictionary says and what my guru told me to memorize. Not good, not a good argument, not at all. We have the fallacy of democracy. The hooded monks voted for my definition. Well, yeah, we belong to a different club here. We don't have these hooded monks over here. Here, you have to defend your definition, like you see down there below. You must defend your definition in the Colosseum with sword and shield. Okay, if you can't be a critic alone, you have to put something in exchange. You have the critic who says, "Oh, the boxer should have hit him with a right or with a left." Yeah, that's easy when you're the critic down there in the audience. The scientist, the definer, the person who defines, he's got to be the boxer in the ring. He can't be the critic. So you got to be a little more than a skeptic or a critic. You got to get in the ring, propose a definition, and defend it. That's the way it works in science. Okay? And I know a lot of people don't like that because they're not used to that kind of thing and they don't want to get into the ring. They just want to, from the outside, say, "Oh, let me tell you that you're wrong." Okay, so I'm wrong. Tell me what's right. That's the way it works in science.